Okay, now that we know what an array and a linked list is, we can talk more about them and explain what are the pros and cons of each data structure. Okay, so if we want to store an information, let's say we want to store 1, 2, and 3. 1, 2, and 3 in array, that's how in an array, that's how you store it. But in a linked list, if you want to store 1, 2, and 3, the same thing, you would need to store, let's say you're storing 1, and then you would store the place information, let's say it's 20. In the place 20, we store 2. So we have 2 here, and 2 stores the place information of 3, which let's say it's 81, and that points to 81, which stores the number 3, and number 3 stores, let's say, null, which tells us that it's over, right? The linked list is over. There is no other information element to point to. One positive of using an array is something called random access. Random access basically says that if you want to find, let's say, the second element, you would find it right there. If you want to find the third one, you would find it right there. So looking for this and looking for the third one is the same amount of time. It takes the same constant amount of time to find any element. If you want to find the 1000th element, you can just go there and you'll find the 1000th element. Another positive of an array is that you just only store the element itself, 1, 2, and 3. But in a linked list, you store the element and also the information of the next location. So you're actually storing two things, which means that you're going to use more memory. In array, you use less memory. You only store the element because you know the other element is just right next to it. Another positive could be that because they're stored next to each other, it's easy to actually compute with them, and they're using less memory, and therefore they have better performance. Now, let's move on to the linked list. A positive of linked lists is that removing and adding an element is pretty easy. In an array, if you want to add an element, you kind of have to like move everything to another place and add that thing. Or if you want to remove, let's say you have like a very long array here of multiple elements, and if you want to, let's say 1, 2, 3, 4, 5, and 6, let's say you're removing 3. If you were doing that, 1 and 2 would still be the same, but 4 would move here, 5 would move there, 6 would move there. So you're basically taking them, moving everything to one left, which is computationally expensive. But in a linked list, let's say that you're removing 2 here, all you have to do is change this 20 to 81, and now this one points to that. We don't have these. Or if you wanted to add something, you would just add the new location, 23, and it would point to 23, and that would have your new place, and that would point to null. So you don't need to actually move things around. So we can come to a conclusion that if you know how many elements you're going to use, a set amount of elements, it's not going to change, then array could be better because it's actually faster and you can access the elements faster. But if you're actually going to add things and remove things constantly, probably a linked list would be a better choice.